Afternoon, everyone. If you're stuck behind a pillar and you can't see, feel free to move. If I say something you don't agree with or you've got a question, stop me. I understand I'm the last thing standing between you and a cold beer, so I'll try and get through these. All right, so for those of you who don't know me, I'm Clint Brown. I work for CADline. I've been around the CAD stuff for a little while. I was very lazy with my About the Speaker slides. That is an Autodesk University 2013 slide on top of last year's slide, on top of this year's slide. I've designed a few different things in my day using all sorts of different CAD products, including Inventor. Started my CAD journey in AutoCAD release 10 in DOS and moved through certain different things as we go. I've been using Inventor for the last 10 years and I've presented a few Autodesk classes and attended a few AUs. So hopefully this won't be too bad. All right, so the name of the class is Need for Speed, 102 Productivity Hacks for Inventor. This happened because I thought they'd never choose the class. We're coming up with some ideas and someone said, what about 60 tips in 60 minutes? And I said, oh, that's been done. So we said, well, what about 100 tips in 60 minutes? It's like, well, that's been done. And it turns out I'm doing 105-ish in 55 minutes. So it's going to go pretty quick, but stick with me, you'll be okay. So it's going to bounce around a little bit, but there's some method in my madness. We're going to get into the first tip, and part of this tip will explain something else as we go. So the first thing is selection filters in Inventor. These are one of my favorite things to use. Every environment in Inventor has a different set of selection filters. So parts automatically by default select parts and edges, faces and edges, assemblies select components, and drawing select edges. And you can change your selection priority inside of different environments to give you different options, which is really handy. So you could be in an assembly and choose a body, for instance. Now, every single slide has additional data because I know I'm going to be going very fast in certain periods of this. So if you see a link down the bottom, it's to one of my blog posts. All right? Unlike these other classes, everything you see here has come from one of my blog posts or one of my colleagues' blog posts. So I'll try and give props to people who did things as we go. So that link down there is to a blog post. So get the handouts at the end. It'll help retain some of this stuff. Right, so let's look at these selection filters. This is an assembly, and we can change our selection priority to the default, which is components. And obviously, I can select components. But what's really useful is obviously I can go and change that to parts, and I can go and pick a specific part, and I can go and look at its eye properties, or I could open it or do something like that. I can also go and change things, for instance, like bodies, which belong to a part file, but I can see that from an assembly level, which is really useful. In a part file itself, remember the default here is faces and edges, but here I've got sketches selected, and I can change that to something like bodies, and I can actually explore the solid bodies inside of my model, and I can then even change this to select features. So if you're trying to edit a part that someone else has modeled, going by feature is a good way to figure out where you are. Right, you all with me? Not too fast? Good, everyone's awake. Right. To get to your selection filters from any environment, shift right mouse button click, and this menu comes up and you can change your selection filters. Okay, this is a really interesting tip a lot of new users miss. If you've selected a bunch of stuff in Inventor that you didn't mean to select, don't cancel out of a command, just hold down Control and deselect what you don't need. It works in all of the environments I've come across. Really useful tip, something I use often. Right, isolate. You sort of saw a preview of this earlier. Sort of an overlooked tip, but if you click on a component, you can right-click on it, go isolate. You can get away with in terms of performance as well. A lot of newbies have issues with their zoom direction. From the show of hands earlier, I'm sure you guys have all sussed this. So under display in the application options, you can reverse your zoom behavior. Right. Rendering. You can save out stills of a ray trace while it's going. So this is a very simple one, but if you've got a really complex ray trace going, you can hit save and actually export out images while that ray trace is going on, so you can get some sort of previews of where you are before you do a final render. All right, this is one of my favorites. Inventor has nice environments inside of it, but you can actually keep all of the shadows and reflections of an environment, but turn the environment off. Right, so how many people remember the yellow mini in a car park? Yeah, some hardcore old school Inventor users. Right, so in the old days we used to have a chrome reflection and there was a yellow mini in a car park, And we don't need that anymore, so if you have a look at this little video, you can see the shadows and reflections, or the reflections at least, coming from this environment. And if we go into the view settings, we can turn off the scene, but keep the reflections. So that's now still reflecting the scene, and it's a nice little tip for visualizations at least. Something that's not mentioned in here, but I think it was 2018.2 or 2019, we can now export out images with transparent backgrounds as well, which is really cool. Right, who designs plastic parts in the room? Awesome, you'll like this. So Inventor's got a whole tooling suite inside of it. Now you don't have to go away and learn the tooling suite. Just some interesting tips will help you design better parts. So if you go and use some of the tools, some basic setup, choose a material, go in and specify a gate location, so your injection point. Right, in this instance, I'm going to put it on the front of this spigot. And then just go with the default processing parameters and run a part fill analysis. That part fill analysis is going to pop up with a little report after a little while. And there's a couple of interesting things you can get out of this. So if you're dealing with an injection molder who tells you, you know, I estimate your cycle time is going to be X and I've got to run it on my biggest machine and he's going to charge you more money for it, you can go back and say, well, actually, I've got an idea of what the processing time should be, or my cycle time, and what my injection pressures are, so let's discuss this. Right, the next thing to think about is that your part fill analysis is awesome. So all of this comes from Moldflow. It was put into Inventor in the 2010 release, and there's some reports you can see on the left-hand side there. So this is the plastic flow report. You can see in this area here that the materials are going to wrap around that spigot. So I'm expecting to see a weld line. And if I look at my weld line report, I don't know if that's visible on the screen, there's a little line there. That's where I'd expect a weld line. Right. The other thing is it's telling me that I'm going to have some quality issues, and those are probably going to be sink marks in those areas, and that's because I've got uneven material thickness. So I've got a lot more material over there. We expect shrinkage. So all of a sudden, if you're designing injection molded parts, you've got some tools inside of Inventor that you probably didn't realize you had that are going to make your life a lot easier. Right, and the last tool in here in the injection molding sort of category is that Inventor will actually suggest the best gate location for you. So I went in initially and I put my gate location on the front of the component, and Inventor's come back and said, actually, the best place to put it is on the back face. So I'll get better results based on that. So bear that in mind. Is that useful? Yeah, some nods. Good. All right. Your application options in general, so tools application options, you can share these with your colleagues by importing and exporting them, but there's a caveat to this. A few years ago, I was in Ireland with a rather large Inventor user. They had about 20 different users, and their admin, a guy called Shane, set up application options for the company, and he shared this XML file around with all the users, and the username Shane was on everyone's PC. And later on in the year, their manager went off to try and figure out who'd been doing what. And Shane was the only productive guy. In fact, he was super productive. He was 20 times more productive than the next guy. So if you do share your application options, just make sure that you change your name. All right. On that topic, a really nice addition to 2019 is now the ability to migrate your application options. So there's two things in here. You go to Tools and Migrate Settings. Choose the program you're coming from, so 2018 in this instance. Your interface customizations, so the right-click menu stuff that we spoke about, and all of your keyboard shortcuts, and then your application options, and hit a tick box and it'll pull them through for you. So you don't have to go and set everything up again. It'll just come through nicely. Works really well. Yes?
Does it migrate also to template?
Sorry, I missed that.
Does it migrate also to template locations?
Yes, if that's in your application options, it will do. Yeah. So the question was, does it remember my template locations? The answer is yes, if it's the defaults, but just remember as well that your project files can also overwrite that, so it does sort of depend on your setup. Just okay. Inventor's got a team web in the background, and there's a default URL there, and the idea is why not set something useful in there? Your company intranet, my blog, Twitter, whatever it might be. You can actually put some useful information inside of Inventor that you might want to use. All right, so onto some sketching tips. This is courtesy of David Gate. You can add arcs to the end of your lines in the line command. So the way to do this is to go draw a line and then pull your mouse back to the end of go back to the end of that point and sort of click down and exaggerate out an arc and you'll be able to draw an arc from the line command. So you don't necessarily have to come out, choose arc, you can do it from there. It's a little bit awkward to explain, it's something you kind of got to try, works really well, give it a go. Right, the next one is inferred constraints. So inside of Inventor, we go in, we set up a bunch of inferred constraints in our sketches, and sometimes they become irritating. So if I was drawing that line there and I didn't want it to be parallel, if I hold down Control, that inferred parallel constraint won't snap. So you might be drawing something and go, I actually don't want that to be parallel or perpendicular. Hold down Control and you'll be able to override that inferred constraint. Okay, trim and extend. You can reverse the behavior of the trim and the extend command by holding down Shift. So if you're in the extend command and you hold down Shift, you can trim. And if you're in the trim command and you hold down Shift, you can, the other way around, you get it. All right. While I was prepping for this class, I learned something. I found the sketch regions properties. So on any activated sketch, you can right-click on it, go to region properties, and click on a region, and you get some phenomenal information. You get your moments of inertia, your areas, your perimeters, just a bunch of data that I didn't know you could get. Really nice little tool. I was really glad I learned something while I was prepping for this. Okay, dimension visibility. If you've got a sketch that you want visible, you can actually turn off the dimensions and you can still see that sketch within your model, which is pretty cool. Any sketch inside of Inventor can be exported as a DXF. So just right-click on the sketch, export as DXF, give it a name, and you'll be able to open that sketch inside of AutoCAD. Give it a second to fire up in the background and open. And there you go, there's your sketch. Right, another tip is you can change the display of the line type and color. So again, right-click on the sketch, and you'll see in this instance I'm going for green lines that are dashed with a line type scale, and there they go. Right, equal spacing. This is an interesting tip, something I always teach new users. So add in your first dimension. I don't teach them to dimension as quick as I'm going to do the next few. But the idea is just to make all of these dimensions equal to each other. And then the last one to accept an overridden constraint. So this becomes a driven constraint. And if we make the first and the last, the first and the last dimensions equal, it'll equally space all of those lines. And if I then change the overall, obviously it'll pop together. It also works on something simple like 2 dimensions. So we just make one driven, make them equal to each other. It'll always auto space and put them evenly spaced for you. Right, naming parameters on the fly. How many people in the room actually bother to name their parameters? Okay, I can be friends with some of you. Please start naming your parameters. Now, one of the cool things I added to Inventor was the ability to name parameters on the fly. Right? So if you, in a dimension dialog, for instance, like this, if I start adding a name, so you can see that it says height equals, Inventor doesn't know what that means yet, that's why it's red. But as soon as I put a dimension in there, 25, it goes, you're clearly renaming this parameter, and it sticks it in. So you'll see that it was originally D46, it becomes height. So this is what it looks like in action. I'll name the parameter, it goes from red to black, and then that dimension is actually now named height, for instance. So it's a very quick way of doing it, and you can do this everywhere in Inventor. If you're adding a fillet, you can actually put there external fillet equals 3 millimeters, shell equals 7, whatever you want to do as you're going through. And it just means that when you go back into your parameters dialog, everything's there in its names. You don't have to go and rename things after the fact. Right, your end of part. You can delete everything under your end of part simply by right-clicking on it and going delete all features below end of part. Quite useful, something I use quite a lot. An interesting quirk, if you roll up your end of part and save your file size reduces. So you'll see in this example, it's a very simple part, but I've gone from 384 megs down to 218, all right? And there's a little link down the bottom that I wrote, which is an iLogic routine, which will take a part file, roll its end of part up, save it, and attach it to an email so you can send it to someone if that's something you want to do. Right, flat faces in part files. Any flat face in a part file can be exported to DXF. Right-click on the face, go export to DXF, and really cool for things like gaskets. So that face will go out. We'll open this up in AutoCAD, and we have a one-to-one gasket, perfect DWG, or DXF in this instance, that I can use for laser cutting or something like that. Right, mirror solids. this is something relatively new, something I like to do. So if I've got a complex model, I don't want to sit and go and select all of the different features. I might have missed out a fillet or a hole, or it might fail. So I like to use mirror solids. And we had a bit of a discussion about this in the office, and I lost a bet. I said that if you did a mirror solids, absolutely 100% of the time, the file type would be smaller. I lost. In the example I chose, the file was actually bigger. But they do tend to behave slightly better and compute quite well, so I stick with mirror solids. Right, as you've all been using Inventor for a long time, this next tip is old hat, I'm sure. But if you're drawing something in the middle of geometry, use the slice graphics or the shortcut F7 to look inside of that geometry. And as a bonus, use the project cut edges to get your edges projected if that's something you want to do as well. Right, the split command. Who uses the split command? Yeah, cool. So there's a few different use cases for this that I really like. If you do any FEA and you need to apply a load to a specific area, use the split tool. Go in and split a face and use that face for an area to apply your loads. If you need to apply a different color to a face, you can use the split face as an alternative to decal if it's something simple. And to use the tool is pretty simple. Go in, it's the first option. Choose your sketch that you want to use as a split tool and go and apply this to the faces. And my result is something like this. Okay. The next option is to trim solids. So we can go in and we can use a line in this example to trim this solid. We're going to cut the top off. But remember, you can use other solids. You can use work features, and you can use surfaces to trim solids as well. All right, and the last one in there is the split solid. So in this example, we're going to use a work plane and we're going to split this solid in half. So we get two distinct solids. But again, surface, work plane, sketch, all of those would work, and we get those two distinctive solids there. Right, you can convert your multi-body solids to assemblies simply by going through a wizard on your Manage tab. So go Make Components, and you can turn that into an assembly. One of the new features from Inventor 2018.1, which I really like, is the parameter filter. So if you've picked up someone else's model and you don't know how they got there, there's a little filter down the bottom which you'll see. And as I click through this model, so you'll see in a second, I'll clear that selection. And when I click on the shell, I can actually see that the thickness there is 0.5 millimeters. And if I now click on the ribs, I can see all of the parameters that we use to create those ribs. Probably one of the most exciting, boring features that has been added to Inventor. If you've got to deal with someone else's geometry, I think that's a lifesaver. All right, fillets, and all fillets and all round. So this is something inside of your fillet tool that is very useful. If you design plastic components or cast components and you need a minimum radius on things, go and use this tool. In this example, what I've done is I've hidden a feature above that fillet. And when I go and activate it, I can go and edit this. And what's really remarkable is if I sort of pull this out and make it bigger than it was, that fillet will go and resolve itself. If I change it again and we go, what do we do this time? Right, so the next thing we're going to do is we're actually going to pull that hole all the way through, and that's going to mean that we're going to need fillets on the back side of this component, which it'll do for us nice and easily. So you see that fillet resolves, and we have a fillet on the back as well. And if we turn that from a cut to a join and actually added material to the top of this component, guess what? It works as well. So really, really, really useful. Something I've used quite a bit with castings, and really nice piece of functionality. Right, so 2019 brought in a new hole command, and you can now save hole presets. If you've ever done anything that required holes, this is really nice. Really easy to do as well. Just go and specify the hole and then click the little plus button and give it a name and or a logical name, and you can reuse it. So you'll see in this example, once I've saved that, I can go and apply a new hole. And once I've placed it, I can just go and choose the preset I've created from the drop down, and it'll go and apply that hole for me, which is really nice. Now, one of the things that you can't do just yet is you can't edit these presets. But you can sort of edit them as a workaround. So go and choose the preset you want, make the changes you want, save it with the new name, and go and delete the old one. There's some guys in the room who might bring in an edit, I don't know. All right, your presets can be shared, so they sit inside your application options. So if you put that location on your server, you can share presets with you and your mates, which is quite useful. Another selection tool is the select tangencies. So in this instance, I've right-clicked on something and I've gone select tangencies, right? And this allows me to do some clever things like perhaps change the color of that, or if you're doing something like direct edits, that might be quite a useful way of grabbing a bunch of different faces to push and pull up and down. So think about where you can use that sort of tool. But has anyone learned anything yet? Yeah, good, good, good. All right. So this was something that came up on a tech support call. Someone wanted to apply a flange to that face, but they only wanted it to be 10 millimeters wide. So the trick here was to go and have a look at this little chevron button, or the extra, whatever we'd like to call it. And inside of here, we can add a width fillet. So we can actually go in and say, well, actually what we want to do is add in a width fillet. We can specify where we want the offset to be. We can then put in our dimension of 10. And our little flange is added and cut back perfectly. So really nice example of these little chevrons inside of Inventor. They're all over the place. Go and explore them. There's lots of additional functionality hidden away that you can get to and you can use. All right, Inventor has some pretty cool tools around perspective. So if you're ever doing a render, make sure you do your renders in perspective because they just look better. Try not to work in perspective all the time because it's going to slow your graphics down a little bit. Right, a tip for perspective is if you hold down Control, Shift, and F3, you can adjust your depth of field. So you'll see here we can actually choose almost the level of perspective we're going to see, which can be quite cool for renders as well. That tip comes courtesy of Luke Davenport. All right, so here's another trick. This is not a render. This is somewhere between a screenshot and a render, a quick and dirty image for a customer. So let's say, for instance, our customer is the tobacco dock and they make graders. What I'm going to do is I'm going to go into my application options and I'm going to change my background image under the colors tab here to a picture of the client's site. All right, so this could be where this product's going to live in situ, and I'm going to apply that. So this is now my background inside of Inventor. All right, now what I want to do is set this to perspective so that it looks decent. All right, and I could use that Control Shift F3 if I needed to adjust it a bit more. And then what we're going to do is go into our View tab, and I want to go and look at turning on my shadows. Right, so turn all the shadows on. And you can see that those shadows don't quite match the picture at the moment. But that's okay. We're going to go into our lighting settings. And what you can do is you can tell your shadows to follow a specific light. So in this instance, we can say follow light 1. You see those shadows move. And I can then go and set the density of this shadow. So I'm going to try and approximate what I've got in the background. So you see it's very dark there. I can make that slightly lighter and get it within reason what I can see on screen. It doesn't have to be perfect. And then I can adjust light 1 to adjust those shadows so that they sort of approximate what I'm seeing in my background image. Okay. And once I'm happy with that, I can send out a PDF or a screenshot or whatever I like. So it's a real quick way of getting something out that sort of approximates, as I say, somewhere between a render and a screenshot. Okay. This is one of my favorites, assembly folders. You can grab a bunch of components. So in this instance, these two axle sub-assemblies. Right-click, add to folder. I'm going to call that folder wheels. And from this folder, I can now do things like isolate, and I can look at just those components. But I can now treat a bunch of components as one thing. So you can even go in and suppress those, etc., etc. Right, so if you've got a really complex assembly structure, drag things into assembly folders and start making sense of your assembly that way. Right, virtual components. Who uses virtual components? Awesome. One of my favorite things in Inventor, really useful for things like nuts and bolts that you don't want to model, or cable ties, or Loctite, or glue. So the idea is, click on your create button in an assembly. Your create and place dialog box is going to come up, but there's a little tick box which says virtual component. And what I love about these is that you can now see these in your bill of material. So there's a little bonus tip down the bottom there, but what I can do here is I've got a bunch of virtual components inside of assembly folders. All right, so this could be something I use all the time. And what I can do with this is I can actually go, you can see them on here. so that they're on my BOM. But I can actually save this as a template file. So I can go File, Save Copy As, Template, and I'm going to call this one Consumables. All right. And the next time I go and create a new Consumables assembly, my start point has those cable ties, boxes, and whatever else I wanted in my assembly file. So very, very useful. All right. Something Inventor doesn't do is display the mass of the full assembly on a BOM. So you can fire up Inventor's bill of materials, export it out to Excel, and the only way to get your total mass is to tally them up. So something you can do is very simply create a virtual component and use a very simple bit of iLogic code to add a mass or a custom UDP to that component. So what we get is we'll go and create our virtual component. We're calling this one mass total. And I'm going to go and add a rule. And this rule is basically going to say, go and add the total mass of this assembly to a property called assembly mass, which is a customized property in that virtual component. So you'll see the virtual component is called mass total. I'm just going to add this user parameter to my BOM. And what I now get is, just enable our structured tab there. What I now get is the mass of the other components and the total mass down there. The reason I haven't added the mass to this component is obviously you get some sort of cyclic redundancy. You can't have the total mass on one component. But we now have the assembly mass on the BOM, if that's something you need. The other thing in there is that's left as normal at the moment. You want to make that a phantom part so that it doesn't get, no one tries to buy it. All right. Again, in the BOM environment, you can do a whole bunch of different manipulation. So for instance, inside of here, we fire this up and we realize that there's no stock numbers. You can copy and paste things like the part number into stock number, but you could copy and paste these off of an Excel spreadsheet as well. Straight in, and in they go. What's remarkable about this is that we're actually writing back to the I properties of all of those parts, so it's quite interesting. You can also change the material of a component from here without opening the part. The last one I'm going to do over here before we get into the last couple is you can add what we call an expression. So we can say that make, in this instance, the description equal to the part number. Okay? So no matter what that description is, no matter what the part number is, the description will always match. So it's a bit of math inside of there. The last thing inside of here is we can right click and we can capitalize these. So if your standard says those properties need to be capitalized, you can do it from here. Again, remember that we're actually manipulating the I properties of all of those parts that are listed. So it's really a really good area to do some manipulation. Okay, yeah, be aware if you're using Vault that obviously you can't manipulate properties of files that are checked in. Right, let's talk about customizing your templates. So how many of you fire up your BOM environment every day and then go and enable your structured view and then go and pull in the columns that you'd like to see, like thumbnails and mass and material every day? What you can do from here is go and set up your BOM the way you want, export out your BOM settings. All right, these guys as an XML file. And then what you can do is you can go back to your top level assembly template file. So go File, New Assembly, fire up your bill of materials, okay, and go and import that XML file. Right, I've now got those areas sorted. They're now in there. I can enable my BOM view because I always want my structured enabled in my instance. And then go File, Save Copy as Template again. Save over your standard IAM. And I now have my bill of materials set up the way I want it every single time. I don't have to go in there and mess about. So when I go in New Assembly and I go and place a bunch of components in here, some random parts, I'll stick those in. When I go to my bill of materials, straight away my structure's enabled and everything I want is there. All right, that'll save you a few minutes every day if that's something you do a lot of. Right, tip that I learned from Chris Turner is the Alt drag inside of Inventor. You can grab some edges, hold down Alt and drag them. You can snap geometry together. It works with the mate, the tangent, and the insert constraint. All right, who uses bolted connections? Good, one person. Do you guys use bolts? Why don't you use bolted connections? Okay, go and check them out. They're awesome. So one of the things you can do inside of bolted connections, again in this little chevron or extra area, is that you can go and create presets. So if I go and specify this one specific bolted connection over here, I can give it a name. So in this instance, I'm going to call this pump bolts, and I'm going to save that away. And then what I'm going to do is, the next time I place a bolted connection, I'm going to go and reuse that preset. But what's really cool about this is that if you've specified, say, a specific ISO bolt, when you use these presets again, the distance between your selection doesn't really matter. So you're not specifying a specific length, you're specifying a specific type of bolt, and the tool will go and calculate the bolt size or the bolt length for you, as long as you're still within range of that specific standard. So big time saver, a really, really good tool to be using. All right, does anyone use a frame generator? Yeah, awesome. So this is a little tool I ran across again by accident digging through Inventor. There's a frame member info in the frame dropdown. So you'll see in the frame dropdown over here, we've got a little frame member info. And this is like iProperties, but specifically for frame members. So it'll show you how it was placed, what standard it is, what it weighs, and what its length is from one area. Really nice tool, something I'm a big fan of. Right. One of the new things that was brought in with 2018 is the browser search. So you can search for anything. Here I've done a search for generic, so I can see all of the components that need to be fixed, i.e. no materials specified. I can search for a specific user. You can find any iProperty that's been specified in this search. It's phenomenal. Much better than the old search. If you've ever used the old search, you'll know what I mean. Okay, here's something that is not immediately obvious. If you're interested in doing any coatings on your models, so parts or assemblies, right? The picture on the left-hand side is an assembly. The one on the right is a shrink wrap. And what happens when you fire up an assembly and you go to its iProperties is that you expect that the surface area will be the surface area of the external of this component. It's not. It's the sum of all the surface areas, okay? So in this example, we've got 2,800 millimeters squared for the first option, and the second option is 2,500 millimeters squared. Hey, tongue-tied. So the idea here really is that if you're going to coat something that's an assembly, you probably want to do a shrink wrap beforehand. Does that make sense? Yeah? Okay. So to help you along, I've gone and written a little bit of iLogic code that will go away and automatically create this for you. So you see there's 49 components in this pipe run, and if I run my little rule, what it'll do, you can choose to patch all the holes, and it goes away, and we now have one part, and the surface area of that part is going to be a lot more accurate than of the assembly file originally. So bear that in mind. Okay, new thing in 2019 is shared views. These are pretty cool. You can click on shared views, and you can share a view of your current model. All right, this is going to upload a .collaboration file to the cloud. It's a collaboration view, a light viewer file effectively. And you could be the designer of this, and you could share this link with someone to approve. So maybe your customer. They click on the link, they go straight to the browser, and you can do things like explode and measure, etc., etc. Okay? And in this example, what we're going to do in a sec is we're going to go and do a measurement. We're going to go and ask the user if a specific dimension is correct. So we're going to click on measure, and we're going to go and look at the distance between these two terminals. So we get our dimension in there, and then we're going to ask a question. We're going to create a markup. We're going to scribble on top of this, so it's sort of a snapshot. You can tell I did this on my touchpad because I did a bad job, but you can actually edit it and drag it around. And then we can add a little question. So add a question in here, and the question is going to be, are the terminals spaced correctly? No, are the terminals correctly spaced? And we're then going to send this back up to the cloud. And in Inventor, the Inventor user is actually going to see that there's a comment on this shared view. So you'll see, if we do a little refresh here, that we've now got a comment. So we can click on that comment. You can see that there's a snapshot or a markup. So we can click on that. It takes me to the markup. So I can see the question. And from here, you know, in the collaboration, we can add comments, but I'm going to resolve this one and send it away. Now, the things to remember are that these are temporary snapshots. So they're only available for 30 days. You can extend the lease of them, but after 30 days, that history is gone. Also works with drawings. Okay, one of my favorite topics. Who uses IGES files? Why? Right. The IGES file the standard was last updated in 1996. That's 22 years ago. I'm willing to bet that someone in this room was born in 1996 or later. So think about that, all right? Inventor has some amazing translation tools built into it. You know, we've got any CAD technology now. You can open the native files. So whoever you're dealing with, if they want to send you an IGES file, and they send you IGES files because they've always sent you IGES files, just tell them you want the file. If they don't want to give you the IGES file, ask for a step file. So the step file is an internationally recognized standard. It's been around for over 20 years. It's continually developed, and it's going to give you a much better file than an IGES file. There are some systems out there that write out some particularly nasty files with gaps and surfaces with the wrong direction on them. So think about that. There's a little link down the bottom there that explains even more about this. I'm very passionate about people not using IGES files. Okay, backward compatibility. This is really cool. So in 2017.4, this release came out that allowed for newer versions of Inventor to be referenced into older versions. So what you see on the right-hand side is Inventor 2018. We're going to make some changes to the model. And in Inventor 2017, we're actually going to see those changes come through. So Inventor 2017.4 to be precise. So we're going to make these slots slightly smaller. And once I save this file, you'll see that the little update button will become available on the left. So we save that. Update's available. Click the update. And those changes come through. So this is remarkable. We've never had this before. We can now actually open files or reference in files from newer versions of Inventor. Again, that's part of any CAD. Right, perspective on drawings. So in 2016, they introduced this. You can now right-click on your drawing views, and you can actually choose to show them as a perspective view instead of an isometric view. So you'll see the hydraulic cylinder on the bottom is in an isometric view, whereas the one on the top is an isometric view. Perspective isometric. Okay. You can use AutoCAD for some of your drawings. So Inventor saves out DWGs as a default. And you could save your Inventor DWG file and share it with someone that uses AutoCAD for detailing. So they could open this drawing up, and they can go and add dimensions. Because it's come from Inventor, AutoCAD's actually going to understand your dimension styles and your scales and everything like that. So you can add these dimensions in and happily work nicely between the two systems. So you'll see once I've placed these, I can save this drawing, shoot back into Inventor, and open that drawing up as well. I'm not going to ask about IDW files because I'm pretty sure everyone uses DWGs and that we're all up to speed and using the latest and greatest. Right, so there's Inventor, and from here I can add additional dimensions as well. Right, who uses sheet metal? Who makes sheet metal parts that don't get unfolded necessarily? No one. Okay, cool. Well, this came through as a support call a few years ago. Someone had something similar to that, and they'd done this component. I lied to you guys, there are 2 sheet metal tips in here. And they created a drawing, but they hadn't flattened this component out. Now, although it didn't need to be flattened, you have to flat pattern out your sheet metal parts to be able to use your punch annotations. So bear that in mind. If you're ever trying to add a punch annotation, you can't figure out why it won't add it, why it won't come on, it's probably because you've got a flat part and you haven't actually put the flat pattern onto your drawing. Okay, here's another one. So I've got components over here, and what I'm going to do is change 2 of the dimensions. So I'm changing to 150 and 102. And what I'm going to do is once I've updated the 3D geometry, I'm going to do a file save as and save this component as another file name, I should say. So when I open up the drawing of the original, I can now go to my Manage tab. You'll see the 130s become 150 and the 100s become 102. On my Manage tab, I can go Replace Reference Model. And I can now go and reference in this new version of this file, so the bigger version. And that'll update all of the dimensions for me. So my 150s on there, my 102s come through, and then I can do a file save as. So it's a really good way to iterate through lots of changed components effectively. Okay, sketchy lines. I was very jealous. With the 2015 release, they added sketchy lines to AutoCAD and Revit, and they didn't add it to Inventor. So I was hell-bent on figuring out how to do this. You can take your Inventor drawing, you can open it up in AutoCAD because it's a DWG, and you can actually go to your view, and you can change this view from wireframe to sketchy. Well, give it a sec. Okay, now my Inventor model is shown as sketchy lines. Now, for the hardcore engineers, you're probably wondering why would I bother with that, but for some conceptual stuff, it looks pretty cool. The bad news is that when you open this drawing back in Inventor, it just goes back to normal. But from here, you can save out a screenshot or send out a PDF. So it's a pretty cool way of doing something different. Okay. You can change the sheet color in Inventor. So if you go to Tools, Document Settings, you can go to your color and you can change your sheet color. This is a document setting though, so it's not across all of Inventor, it's just for that specific document. So if you want a white background or a blueprint look, save that as your template file. Right, something else that's pretty cool is that there's two tips in here. One is around precision and the other one is around copy properties. The copy properties tip comes from my friend John Londeros. He writes a blog called Inventor Tales, or at least sort of used to. But one of the nice things is you can right-click on a dimension and you can edit its precision right from here without double-clicking on it. But the cool thing is you can right-click and go Copy Properties. And you'll see that I can then drag a box over all of those other dimensions, and anything that had that additional comma value available is instantly painted. So for AutoCAD users, it's kind of like a match properties, but for Inventor. Right, who does simulation in Inventor? A few of you, awesome. There's no symmetry in Inventor, so you have to use the frictionless constraint. So this is an example of sort of a bicycle pedal here. You'll see that this model's been split up into 4, and frictionless constraints have been applied to those faces where we've split it. The only thing to remember is that we've started with a load of 1,000 newtons. You need to change that down to 250 in this example so that you're not losing or not overstressing the model. And you'll see that our results are pretty much the same. Now, there's a link down the bottom to a full demo of this. It's from the Autodesk Knowledge Network. It's not my own. Go and have a look at that. It's really good. And something else to consider is when you've got your results and you've got a bunch of components that you're looking at, sometimes it's difficult to see what's going on. You can right-click on a component and turn off its visibility. Okay? And you'll see, look at the results. So we've got 44 megapascals up here. When I turn that one component off, it goes down to 27. My results haven't changed, just the view of my results has changed. So we're not seeing that pin anymore, but it's still being calculated. So it's a good way of seeing a little bit more detail on your models. Right, this is one of my favorites. It's an unsupported workflow that doesn't always work. It only works in sort of smallish components. Is while you're in your view with your results and your mesh and your probes turned on, you can export out a DWF file and you can share that with someone. I found it doesn't work very well on big assemblies, but works quite well on parts. Right, direct editing parts. Again, this is something that's really useful if you get some sort of dumb components. So maybe you've opened a step file, you need to make modifications to it. You can go onto your tab to your direct edits. Okay, and in this instance, I'm going to make this component thicker. So I'm going to choose those two faces, and I'm going to add 2.5 millimeters to it, or 2 millimeters to it, I should say. And then I'm going to grab the next two faces, and I'm going to add 2 millimeters to those. Then I'm going to speed this video up a little bit, and I'm going to go and do a bunch of things. I'm going to go and change the radius. I'm going to change the size of a hole, and I'm going to move a hole using these tools. So really, really powerful tools for editing components that you didn't originate. All right. Now, what's really interesting about this is that you're making parametric changes to a model. So you can actually save those parameters and go back and revisit them. So if you move the hole over 5 millimeters, you can actually say, actually, it should have been 10. Go and edit the parameter, and you can move it over. So you've got a really interesting workflow between direct edits and parametric modeling. Right, customize the navigation bar. I see this all the time. Inventor users sit there and they click through the drop downs, and I'm like, why don't you just customize it? You use the same tool over and over again. There's a little, probably not very obvious, but there's a little drop down over there. And you can go in there and you can choose which tools you use all the time. So if you always use zoom window, stick it on there. If you always use zoom, stick it on there. It's a really nice way of speeding up your workflow. Right, inside of drawings, we can set transparency. Right, so you can select a part, select part priority, choose a part, right click on it, choose to make that component transparent. And from there, you can go and look at its edges, go look at the properties. And in this instance, I'm going to make this light gray. And I'm going to change its line type to dotted. All right, so we now get a very different looking drawing. Right, there's a nice degrees of freedom analysis tool inside of Inventor as well. This will go through all of your components. It'll actually give you all your mates. You can click on the components, and you can actually see how those components would move. So you can see in this example, the little arm moves over there, or the leg, etc., the head. He doesn't like that tip. Okay, some code-free iLogic. You sort of saw this earlier. The best way to get into iLogic, if you don't know how to use it, is to start with forms. Forms are really easy to create. You can literally just go to the Forms tab, right-click, add a form, go and grab parameters that you want to use. So I can go and grab these renamed ones over here, drag them onto my form, say OK, and I now have a form that I can use to manipulate my geometry. Right, nice, easy intro to things. Right, so iLogic best practice. Who uses iLogic in the room? Right, a few of you. Okay, I'm sure you've heard this before, but I have to mention it. Keep things simple. Don't try and eat the whole elephant in one rule. It's not a good idea. Comment your code. I'm overrunning, I'm being told. I've got 2 or 3 slides to go. No matter how good your memory is, you're going to forget what you've done or why you did something, so add comments. Try and run external rules where possible. If you've got 1,000 files with 1,000 rules inside of them and you've made a mistake or you realize you need to make a change, it's very difficult to go back and edit them. So use external rules where you can, but there's 2 disadvantages to external rules. They don't run on parameter changes, and they're not embedded into your files if you share them externally. So if you share your files externally, remember to share your rules with them. All right, but you can use forms to link rules together. So you could have a form that fires rules from buttons. And then if you use event triggers, be careful of running event triggers after a file is saved, right? It's fine for exporting out DXFs and PDFs, etc., but don't go and update any properties in the file because you'll effectively dirty that file. Right. You can fix overridden dimensions in Inventor by selecting all overridden dimensions, going into that dialog box, going edit, deleting the overridden dimension, and just unticking the hide dimension, right-clicking and repeating that, and that'll clear all of your overridden dimensions. Since 2016, we've been able to scale our views by dragging the little arrows on the corner. Really useful. And my last tip, if you're a Vault user, do we have any Vault users in the room? Awesome. How many times have you hit open and then gone, oh, I meant to go open from Vault? Down the bottom of your open tab is a little open from Vault button. You can click on that. But better than that, you can customize your I forgot what it's called, your quick access toolbar, so that you've always got an open from Vault on there. Or last but not least, edit your custom user commands and just add an open from Vault to your ribbon, and you'll always be able to open from Vault. And that is my 102 tips. Any questions? Thank you for staying awake through the graveyard session.